absolute values. First of all, I'll start with the definition. An absolute value is a distance from the origin. We use these two bars to represent an absolute value, and we read it as, for in this case, the absolute value of x. But it's two straight up and down bars will represent absolute values. Now, when we talk about absolute value being a distance, and it's really important every time you think of the word absolute value that you are comparing it to distance. Because when it comes to distance, we always have two directions that we can go. So you always have a start point wherever your origin is. And if you are going to go 3 units, as in this example that's written up here, I can go 3 units to the right of my origin. I can go 3 units to the left of my origin. That is because whenever we do an absolute value of a distance, or absolute value is distance, you always get a positive representation. Whether you go left or you go right, it doesn't make a difference. You're always going positively. And that's why you always hear always absolute values are positives. Because absolute value is truly distance. Whenever you take the absolute value of a negative, you get a positive. And whenever you take it of a positive, you get a positive. So it goes to the idea of when you go to Phoenix, you go 90 miles, but when you come back, you still go 90 miles. You didn't go a negative 90 miles. An absolute value is a distance, and you need to keep that in mind. Because when we do distance, we get 2 directions. 2 directions means we have 2 answers. So every absolute value is going to have 2 answers. And that's going to be important. Every time you hear the word absolute value, you think distance. But the other thing you're going to think of is do it twice. Because absolute values have 2 answers. Always. We have to account for both directions, if you will, of our number line. So in order to do it twice, we need to be able to set up 2 different problems. The first problem is very simple. It's as is. The way the problem is written, just without the absolute value bars. So the first way is however the problem is given to you. The second way is to change the signs of everything not in the absolute value bars. Absolute value bars are just that. Absolute. Nothing goes in, nothing gets out, nothing changes inside of an absolute value. So the second way is for everything outside to become opposite or to change their signs, because that's going to be the other direction that it goes. So once we have these 2 problems, the first problem as is without the absolute value bars, and the second one with everything changed outside of it, then we get to solve normally. When we solve our normal, we combine like terms, we move our constant, we move our coefficient, but we always need to graph it. Because we're going to be talking about absolute values, we are going to be graphing. Now, if it's an equal sign, there's no shading involved. But if there are inequalities, we're going to have those open, closed circles, and we are going to be having those shadings. So you still have to apply the rules from the previous sections when it comes to graphing. When we graph inequalities, if we graph an absolute value inequality and we get our picture going away from each other, we need to go back and make sure we write the word or between our solutions. When we graph and the picture goes together, that's going to be an and or a compound. We're not going to write the word and. We're going to go back and write it in the proper format of least number, greatest number, variable in between, and the less than symbols in there. So we're going to look at several examples here on solving these absolute values. Keep it in mind, when we solve our absolute values, we are going to do them twice. First time as is, and the second one will be with everything changing outside of the absolute value. All right. So example number 1. This is an equal sign. With our equal sign, we won't have to worry about graphing and shading, because an equal sign is just that. It's going to be 2, it's going to be -5, it's going to be whatever it is, but we don't have to worry about graphing with that. So 2x minus 5 is 5. First one, as is. Just get rid of the absolute value bars. Then we need to do it where we switch the signs of everything outside. Well, an equal sign doesn't switch. An equal sign is just an equal sign. But a 5 is going to become a -5. The absolute value bar, everything inside stays. Everything outside changes. Now it's a matter of solving. So 2x, add that over is 10. X is 5. 2x is 0. So x is 0. So x is 5 and 0. There's your solution set for an equal sign. Okay, so let's start working on some inequalities. Let's go x minus 1 greater than 3. And we're going to solve this one. First thing we do is write it as is. And then we're going to write it by changing the symbols and signs of everything outside. So x minus 1 stays. A greater can change. A greater changes to less, and the positive 3 becomes a -3. Now we need to solve it normal. X is greater than 4. X is less than -2. When I go to graph this, number line, variable, origin, my points, I now look at open or closed circle. Well, they're both open. And I am greater than 4, so I am to the right. I am less than -2, so I am left. The picture tells me I am an OR. And if I'm an OR, I must go back and write the word OR in my solution set. You must go back and write in OR in your solution set. If you don't, you will lose points. All right, let's try x plus 4 is less than or equal to 3. Again, solving these are not really an issue for us. It's just when we're done making sure, is it an OR compound or is it an AND compound? So as is means we leave the x plus 4 and we switch everything outside. So first time we're going to leave it alone. And the second time, leave the absolute and switch everything else. So an as is and a switch. Subtract the 4, so we get -1. Subtract the 4, and we get -7. So when I graph this, let's see, -7, -1 origin, and there's a label. I'm going to have a closed circle on both of them. This says everything x less than -1. So less than -1 means I'm going left. everything greater than -7, well, greater than -7 is to the right. So notice they do overlap in between. That does make this an and problem, but we don't go back up and write the word and. We must write it as a compound solution set, and the solution set is smallest to largest with the variable in between, and then our less than symbols. In this case, they're equals. And that's going to be our solution set. If you go back and put the word and, you would lose points for not writing it in the proper compound notation. All right, let's look at a couple specials. All right, and these are what we would consider special. I'm going to write them all up here. So the absolute value of x is -7. The absolute value of x, -4, is greater than or equal to -11. And the absolute value of 2x plus 1 is greater than -2. Now, if we look at all of these examples, these 3 examples, compared to the first 3 that we did, notice whether it's an equal or whether it's a greater or whether it's a less, they were all positives. These last 3 examples are negatives, and that's what makes them special. Because it's some absolute value of equal, less, greater, a negative. When we think about a distance, and that's what an absolute value is a distance. Can a distance ever be a negative value? Whether it's positive, whether it's 7 or 1/2 or any other number in between. Is there any distance that is a negative number? And the answer to that is no, meaning there is no solution. Okay, so let's come back over here. This is a distance. Is there a distance that is greater than a negative value? Well, on a number line, whatever, here's my -11. Is there a value that is distance that is greater than it? Absolutely. And it's all of our positives. There is a value that we could set up and do this. Matter of fact, every value we put in will come out to be true. For example, let's put in a -8. -8 minus 4. Is that greater than -11? Well, that's the absolute value of -12, which is positive 12. Yes. If I put in positive 8, well, that's 4. Yep, 4 is greater than -11. No matter what value is put into x, the absolute value of it will always be positive. And a positive will always be greater than or equal to a negative. So if this is always true, we use all real numbers, because everything we put in there will always be true. Okay? So let's try this one. This is a distance. We know a distance is positive. If a positive is less than -2, can that ever happen? Can a positive ever be less than a negative? And the answer is no. So there is no solution. So when you have these specials, and the specials only occur when it's a negative on the other side. When it's a negative on the other side, you get specials. When you are special, you are either nothing or you're everything. If you are an absolute value of a positive, and that's what those first three examples were, well, then you have two problems you have to work out. And you have to decide, are you an or, are you an and? Okay, so hopefully you have that distinction between them. We'll work on the assignment in class.